Now we'll go through a basic intro into forward kinematics and what forward kinematics actually is. So to think about forward kinematics for a sec, think firstly about a robot arm, an industrial arm. We've got a whole lot of rigid bodies, which are the links, the solid parts that we can't deform in any way. And they're all connected together through a series of revolute and prismatic joints. In the case of our robot here, our ABB robot, they're all revolute joints, 6 revolute joints, and our rigid bodies are connecting them together. If we know the angles of all these revolute joints, or displacement for if we've got prismatic joints in there, we can work out the position of the end effector relative to the base. So we know where the base is bolted onto something. If we know all the angles or distances, and we know all the linkages associated with them, we can know the position where that end effector is. And that's what forward kinematics allows us to do. We compute the end effector position given all the joint angles and all the linkage lengths and things like that we have within our system. Now, one thing we need to note is there's only one possible solution. So all the angles are known, and therefore the position of the end effector is determined, and it's fixed. We know where it is based on what all those joint angles are. One other term that we'll be looking at, and we'll be looking at this one later on in the course, is inverse kinematics. So in inverse kinematics, we know the position of the end effector, or the desired position of where we want it to be. We need to know, and we need to work out what all the angles need to be, or distances for prismatic joints, to get to that position. So we're computing the joint angles based on the desired end effector pose. One thing with inverse kinematics, in contrast, is that there's not just one solution like we had in forward kinematics, but many solutions, or even infinite solutions. It really depends on the number of degrees of freedom that are associated and that we're controlling. If you think about it, if I wanted to get to a pose here, I could have my arm in many different locations to get to that particular pose. There's lots of different ways I could manipulate all the joints of my arm, just like you can in one of these robot arms to get to that pose. Some of them might be very poorly optimized, but still be a valid solution and get you to that end effector pose that you're requiring. So the examples we've shown thus far have been with a robot arm, but we can apply this concept of robot joints and these prismatic and revolute joints to pretty well anything. And so we'll go through a few examples first up as we learn the basics of forward kinematics with some very simple collections of 1 and 2 joints as we then build up to higher levels of joints in our system.